What if one single discovery, unlocked faster than light travel, made you bulletproof and let you float in the air, but also meant that firing a gun near a force field would nuke an entire city? That's the Holtzman effect. And the physics behind it are weirder than you'd think. Every technology in the Dune universe, the shields, the starships, the floating chairs, traces back to a single discovery. One equation, one man. Holtzman. The books are deliberately vague about the specifics, and the films even more so, but the internal logic is consistent. Holtzman discovered a way to generate a specific type of field, one that interacts with the fundamental forces of physics in ways our current science can't quite account for. Think of it less like inventing a new machine, and more like discovering a new law, and then figuring out, over centuries, everything you can build on top of it. The best real-world analogy for this isn't a technology, it's electromagnetism. When James Clerk Maxwell unified electricity and magnetism in the 1860s, he wasn't building anything. He was writing equations, but those equations eventually gave us electric motors, radio, X-rays, MRI machines, fiber optic cables, technologies that would have looked like pure magic to someone standing in the room with Maxwell when he wrote them down. One phenomenon. Wildly different applications depending on how you interact with it. The Holtzman effect works the same way. Tune it one way, and you get a field that stops a blade, or a bullet. Tune it another way, and you fold space itself. Scale it differently, and you can suspend objects in defiance of gravity. Same underlying effect. Three completely different technologies. Three completely different ways it reshaped human civilization. And that's what we're going to look at today. Not just what these technologies do, but why they work the way they do, and what real physics, right now, points in a similar direction. Quick thing before we dive in. If you geek out over Dune, Battlestar Galactica, or any sci-fi that takes its own world seriously, hit subscribe. That's exactly what this channel is about, and there's a lot more coming. Let's start with the technology you actually see the most in the films, the personal shield. In combat, every soldier, noble, and fighter in the Imperium wears a Holtzman shield, and watching a fight scene in Dune, something immediately feels off compared to every other sci-fi action movie. The movements are slow and deliberate. Fighters don't hit, they push. They lean into each other almost like wrestlers. And the reason for that is built directly into how the shield works. A Holtzman shield doesn't block everything. It blocks anything moving above a certain velocity threshold. Fast-moving objects, a bullet, a thrown blade, a punch, hit the field and stop dead. But slow-moving objects pass right through, which means the only way to actually hurt someone through a shield is to press your weapon against it and push until the blade crosses the threshold and enters. That's why Dune's fight choreography looks the way it does. It's not stylistic, it's physics. And here's where the real-world comparison gets genuinely interesting, because we actually have materials that behave almost exactly like this. Non-Newtonian fluids. Under normal conditions, they flow like liquids, but apply sudden force, punch it, throw something at it, and it instantly hardens. The faster and harder you hit it, the more it resists. The resistance is proportional to the speed of impact. Sound familiar? Researchers have actually been developing flexible body armor using shear thickening fluids for years. Kevlar panels soaked in the stuff become dramatically more resistant to high-velocity impacts while staying light and flexible. The Holtzman shield takes that same idea and turns it into a force field. Instead of a fluid that gradually hardens under pressure, it's a field with a hard line. Slow enough, you pass through. Fast enough, you don't. No exceptions. But then comes the lasgun problem. And this is where things get dark. A lasgun fires a continuous beam of energy made of photons moving at the speed of light. There is no slower way to fire it, which means when a lasgun beam hits a Holtzman shield, you don't get a deflection. You don't get a shutdown. You get a catastrophic subatomic explosion. Both the shield and the lasgun are destroyed. Everyone nearby is killed, and depending on the scale, you're looking at a detonation comparable to a tactical nuclear weapon. The real-world analogy here is matter-antimatter annihilation. When a particle meets its antiparticle, a proton meets an antiproton, an electron meets a positron, they don't bounce off each other. They convert entirely into energy. Every bit of their mass, gone, released as radiation in an instant. It's the most energetically efficient reaction in known physics, and it's completely uncontrollable once it starts. The Holtzman-Lasgun interaction has the same character. Two things that are individually stable, but whose contact releases all available energy simultaneously. And this single fact reshapes the entire political and military structure of the Dune universe. Think about it. If firing your most powerful ranged weapon near an enemy shield guarantees a nuclear-scale explosion that kills your own troops as well, you simply don't use it. The lasgun becomes a deterrent, not a weapon. Both sides effectively agree never to combine these two technologies on a battlefield. That's not fiction. That's mutually assured destruction. The same logic that defined the Cold War for 40 years, nuclear weapons so catastrophic that using them means losing everything, gets reinvented in the Dune universe through a quirk of field physics. And the consequence is identical. Warfare doesn't escalate to its most destructive form. Instead, it regresses. Armies go back to swords, knives, and hand-to-hand combat. Not because they forgot how to build guns, but because guns became useless, and lasguns, on the other hand, became too much dangerous and unpredictable. Now we scale up, dramatically. Everything we've talked about so far fits in your hand. A shield generator worn on a belt, a small lasgun carried over a shoulder. But the Holtzman effect doesn't care about scale. Push enough power through the same underlying principle, and you stop blocking swords and start bending space itself. This is how humanity travels between stars in the Dune universe. Not by building faster engines. Not by putting people in cryo-sleep and crossing the void over thousands of years. The Spacing Guild folds space, takes 2 points in the universe that are light years apart, bends the fabric of space between them until those 2 points are touching, and steps through. The ship doesn't travel the distance. The distance stops existing. And here's the thing, this isn't pure fantasy. The mathematics actually works. Einstein's general theory of relativity describes gravity not as a force, but as a curvature in the fabric of space-time. Mass bends space, and other objects follow that curvature. But the same equations that describe that bending also allow, mathematically, for far more dramatic distortions. Wormholes, formerly called Einstein-Rosen bridges, are solutions to Einstein's equations that describe a tunnel connecting 2 distant points in space-time. You enter one end, you exit the other, and the distance you've crossed in normal space could be millions of light years. The math permits it. The problem is the same: exotic matter. Wormholes collapse instantly without something holding them open, something with negative energy density, which we have never observed and may not be physically possible. General relativity tells you how to fold space. It just doesn't tell you what to fold it with. Now, if you've watched other sci-fi, you've seen this problem solved in different ways. Stargate builds it into the premise literally. Stable wormholes held open by a ring of alien-engineered exotic matter with coordinates dialed in like a phone number. 7 symbols, a destination locked, a stable tunnel opens for 38 minutes. It's elegant, and it's honest about what the physics actually requires. A physical structure sophisticated enough to hold the fold open and precise coordinates to aim it. Battlestar Galactica's jump drive works similarly at the conceptual level. The ship calculates a jump solution, feeds exact coordinates into the FTL computer, and executes. Wrong coordinates? You exit inside an asteroid. So you calculate carefully, you verify, and then you jump. Both of these treat interstellar travel as an engineering and mathematics problem. Hard, dangerous, but fundamentally solvable with enough computing power and precise enough measurements. Dune looks at that assumption and quietly tears it apart. In the Dune universe, folding space isn't a coordinates problem. It's a perception problem. The Holtzman engines can generate the fold, but the universe between here and there, during that fold, is not stable or predictable in any way a computer can model. The path through folded space is not a calculation. It's closer to seeing the future. Every possible trajectory, every possible exit point, every hazard that exists in a space that is temporarily not behaving like space. A navigator has to perceive all of it simultaneously and find the one safe path through. No machine can do this. In the Dune universe, thinking machines are banned entirely. But even setting that aside, this isn't a processing power problem. It's a consciousness problem. And the solution is spice. Guild navigators consume melange, the spice produced exclusively on Arrakis, for years, decades, their entire lives, until it rewires their biology and perception completely. Their bodies mutate. Their minds expand into something that isn't quite human anymore. And in exchange, they gain the ability to see through fold space and navigate it safely. They don't plot a course. They witness the journey before it happens, and then they make it happen. Which means whoever controls the spice controls all travel between stars. Every trade route, every military deployment, every colony. The entire interstellar civilization runs on one substance, from one planet, processed through the altered bodies of a small guild of mutants. After shields and interstellar travel, the suspenser almost feels mundane. Almost. In the films, you see them everywhere once you know what to look for. The floating ornamental lights in the Emperor's court, the hovering platforms, and most memorably, Baron Harkonnen, whose massive body is being carried by a harness of suspenser fields, letting him drift through rooms with an unsettling, weightless grace that makes him feel fundamentally wrong in a way that pure size never could. The suspenser is the most quietly radical of the three Holtzman applications, because what it's doing is the thing physics has historically treated as almost completely non-negotiable. Electromagnetism can be shielded. Space can theoretically be folded. But gravity is the force that won every argument. It shaped the universe, collapsed stars, and has resisted every attempt to screen, block, or redirect it. And yet, real physics has found small, strange cracks in gravity's armor. They don't come close to what a suspenser does, but they point in an interesting direction. The first is diamagnetic levitation. Certain materials are what physicists call diamagnetic, meaning they weakly repel magnetic fields rather than attracting them. Normally, this effect is so small, it's irrelevant. But crank a magnetic field up to enormous strength, and the repulsion becomes enough to physically lift objects against gravity. In 1997, researchers at Radboud University in the Netherlands used a powerful electromagnet to levitate a living frog. The frog was unharmed. The physics was real. It wasn't fighting gravity directly. It was using the interaction between the magnetic field and the frog's own internal molecular structure to generate an upward force, strong, enough to win. The second is quantum levitation, which you've almost certainly seen in those videos that look like pure magic. A superconductor, cooled to near absolute zero, expels all magnetic fields from its interior. Place it above a magnet, and it doesn't just float. It locks in place, hovering at a fixed distance, following the magnetic track beneath it with eerie precision. It's not repulsion exactly. It's more like the superconductor and the magnetic field reach a kind of negotiated stalemate, and hovering is the compromise they settle on. Both of these are real, demonstrated, repeatable physics, and both share something important with how a suspenser logically has to work. Neither of them is fighting gravity head-on. They're not canceling it or generating an opposite gravitational pull. They're using a different force, configured in a specific way relative to the object's own properties, to produce an upward result. The gravity is still there. The object is just no longer fully obligated to obey it. A Holtzman suspenser almost certainly works on the same principle. What's interesting is how casually the Dune universe treats this. The personal shield reshaped warfare. Fold space travel built and sustains an entire interstellar empire. But the suspenser is just furniture, I guess. Decorative lights. A mobility aid for a very fat villain. The most philosophically astonishing of the three technologies, partial mastery over gravity itself, ends up as the one nobody particularly thinks about, because it's been domesticated so completely. So that's the Holtzman effect. One discovery. Three technologies. And each one didn't just change what people could build, it changed who held power, how wars were fought, and what human beings were willing to become to stay in control of it. And the reason this world building hits as hard as it does? The reason Dune feels so different from almost every other sci-fi franchise is that Villeneuve and Herbert never let the technology exist in a vacuum. The shield doesn't just stop bullets. It makes laser guns suicidal and forces civilization back to knives. The fold space drive doesn't just connect the stars. It hands the keys to the entire human universe to whoever controls one desert planet. The dispenser doesn't just let you float. It lets a man so powerful he's become untouchable move through the world, like gravity itself no longer applies to him. Because for him, it doesn't. Which brings us to what's coming next. Dune Part 3 is scheduled for December 18, 2026, and if you know what's in the source material, you know the story is about to get significantly darker. The film jumps forward 12 years. Paul Atreides is now Emperor, ruling most of the known universe, and the holy war he set in motion has consumed billions of lives across the galaxy. The man we watched become a legend is now living with what that legend cost. Villeneuve co-wrote the screenplay with Brian K. Vaughan and has described it as the conclusion of his trilogy, the final chapter of a story he's been building for 5 years. A teaser trailer dropped in March 2026, giving us our first look at Robert Pattinson as the villain Scytale, a face dancer, someone who can wear any identity, which in a story already about manipulation and false messiahs, feels like exactly the right threat. It's also landing on the same day as Avengers. Doomsday, which, look, I'll let you decide how you feel about that. But Warner Brothers has made clear they're not moving. They chose the date first. Personally, I think that's the most Dune thing they could possibly do. The Imperium does not negotiate. I'll have more content covering the lore, the technology, and the politics of Dune as we get closer to December, as well as deep dives into other sci-fi universes that take their own science seriously. Battlestar Galactica, Stargate, and a few others that don't get nearly enough credit for how carefully they built their worlds. If any of that sounds like your kind of thing, subscribe and come back. There's a lot more coming. See you in the next one.